Hello, everyone. It's great to be at a live conference, I guess, after all the craziness of the pandemic, and especially great to be at a conference for network automation, something that dates back for a while for me in terms of how I've been with networking. So thanks specifically to Chris and Scott for making this happen, for the community and your turnout, which shows that this is clearly something that matters to you. And thank you for inviting me. I expect this talk to be controversial. I don't expect everyone to agree with what I say. So please feel free to jump in with your disagreements and let's have the conversations. The only thing I would request is before you say I disagree, I hope you can repeat back to me what you think I said. Because many people don't hear, they're busy reloading what they thought they heard. So life, liberty, and the pursuit of network automation, where I think we for too long have focused on the pursuit part of the network automation. So the question, the theme of AutoCon is why haven't we seen full adoption of network automation yet? And I posit a very simple reason. It's because the benefits of saved time and effort have not been realized broadly and deeply. And when I say broad, I mean there are 400 people in this room, but there are many more who are not in the room, and it is getting them all on board. Many times I've heard people say like, oh, I want to get it in, but the management doesn't approve or something else doesn't happen. So there are a set of well-known factors why the benefits have not been realized broadly. I say deeply because I believe in the language we have used, in the way we have described things, we kind of are actually very confused about what we mean when we say network automation and full adoption. And so I want to kind of focus on those aspects as well. Part of what I want to say is that there are lots of known reasons. People often say, if only everybody just got behind Python programming, it would be all done. We would all be way ahead. Or if only our managements approved it, we would be all ahead. I want to posit a different set of reasons for why I think this has not happened. And these different set of reasons come not from the perspective of whether somebody can learn a skill or not learn a skill. A large part of life, in my perspective, I've seen many great practitioners of the craft, whether it be in compute, whether it be in the arts, whether it be in the sciences, make this specific statement that I think he captured really well. Dizzy Gillespie is a great jazz trumpeter, for those of you who don't know who he is. He made this line, which is, it's taken me all my life to learn what not to play. My question then is not what we can be doing, it's what should we not be doing. What are the things that we believe in that's making us go down a path that's actually causing us to be held back from the full adoption broadly and deeply? And the reason why I think it's important to focus on these other factors is I don't want to be here for AutoCon 21, 2034, and saying, why haven't we seen full adoption of network automation yet? 2034, maybe we'll have self-driving cars. Maybe we'll have, quantum theory sit well with relativity. We may even have gender equality. The US converting to the metric system, not so much. What about network automation? They say history does not repeat, but it certainly rhymes. I don't want the reasons why we are here to rhyme. That's one of the reasons. So every time you hear me look at something and you say, but I can, I would like people to pause and say, it's not about what you can, it's what should you be rather doing, and what are the things to avoid. Why should my perspective matter? After all, as Clint Eastwood said in a movie, opinions are like star, everybody has one. So why should my perspective matter? I think primarily it matters because of the fact that I have been on both sides of the aisle. I have been at Cisco Systems from 1997 to 2012. When I left, I was just a fellow. And I was responsible for a lot of things that people today use, whether it be VXLAN, whether it be the old Catalyst 6500s that people love so much. I was one of the key architects on many of these things. I was the key architect. So that's one of the reasons. And my first journey in the network automation began there. And then I went to Cumulus Networks, where I was the chief scientist, and that put me really in the front line with network operators. Then I wrote a couple of books, and then I started SuzyQ as a labor of love. And it's now evolved into an enterprise edition and something else, but I believe I've sat on both sides of the aisle, and so I have a perspective that I believe is unique. So when does my journey begin? I want to mix in my story of how I began with network automation to arrive at some of the conclusions I reach and talks that we do, because I believe that understanding helps see the perspective from a slightly broader lens, I hope. So it starts back in 2008, 2009, when OpenFlow had come out, and everybody was running around saying, oh my God, OpenFlow, it's going to transform the world. It's going to change everything. And I was at Cisco at the time, and me and my boss were asked to come to a very large organization, somebody who you all know of, maybe you run their laptops are running their operating system, saying, hey, Cisco, what are you going to do with OpenFlow? So we showed up. We said, OpenFlow, terrible. It's 1.0. Doesn't have ECMP, doesn't have this, doesn't have that. So what's your answer? We're going to do Cisco Flow. It's going to be fantastic. It's going to do this and that and that and that. And everybody said, great. So we all shook hands in the room, said, we are going to come back. We're going to do Cisco Flow. I said, great. Now that we all agree that Cisco Flow is going to be amazing, what are you guys going to do once you have it? Assume for a second it's in your lap today. What are you going to do with it? And the chief engineer there said, oh, very simple, Dinesh. I'm going to configure VLANs. What? OpenFlow talks about reprogramming, so you look at the first 2 bits of the IPv4 address and the last 2 bits of the MAC address and then decide how to forward a packet. What do you mean configure VLANs? Oh, Dinesh, do you know what my problem is? I have 500 switches, 1,000 switches. How do you think when I get an OS upgrade, I got to go update? I'm like, dude, do I look like the guy who knows that I'm the architect at the other end? I have no idea what you're talking about. And he's like, I have to manually reboot every switch. What? So that's when it first occurred to me. That was my first intro into the world of a network operator. It's very old, and some of you might say, like, seriously, dude? But yes, that was my introduction. And I think part of the problem we are dealing with is many of the people who build the machines that you use are not the operators. So they don't understand the world that we live in from an operator perspective. And because we don't live in that world, what ends up happening is the abstractions we create are the abstractions of a developer trying to debug the box when you call and say something doesn't work. It's not the abstraction of an operator. So basically what I understood was that automating networks was crucial to scaling. That without automating networks, it was not possible for them to really go large. It reduces repetitive work, and it reduces random errors. Those were the 2 things that I learned from that conversation. Again, you can say this is obvious now, but this is 2008 if you remember. But what it also told me was that a big reason why there has not been full adoption is because OpenFlow and SDN slowed the adoption. For a very long time, when I was at Cumulus, for example, people would come and say, oh, do you do OpenFlow? No. Do you do SDN? No. Oh, so you're not the wrong company because we are in the business of network automation. We are trying to do network automation. So I think a lot of people were waylaid by this. The reason why I think it's the wrong, why it's slowed adoption and why it's the wrong answer is because it's the wrong abstraction. And primarily, any solution that says the people who are the largest practitioners of it have to basically forget everything they have spent their lives learning and start from scratch is a terrible answer. And I think that's what OpenFlow had to do. Everybody's kind of now forgotten about OpenFlow. Even the people who talked about it a lot, like the Googles of the world, with their SDN controllers, have moved away very quietly. They don't tell you this, but they have stopped using their controllers in a bunch of different ways. And they use what we all know of, EVPN, BGP, OSPF, all the time. So this was a mistake for us, and this really slowed down adoption. I was done at that point with Cisco. I was ready to move out, and I thought I was actually done with technology. But then JR at Cumulus called me and said, Dinesh, I want you to come. Here is what I'm building at Cumulus. And what he said was that we want to do to networking what Linux and Intel did to servers really resonated with me because I said, how do the server guys get so good at what they do? They get so good because they can script. One of the biggest problems why network engineers have difficulty getting on board network automation is all the years that they learned the skills, the device CLI is still not scriptable. Someone said, like, when we were talking about this with that large company, we said, like, but you say you cannot automate, but we do have tickle TK. They said, great. Go on the job postings and find me how many engineers are there who understand tickle TK. So it's not sufficient to have a solution. It's also important to have a solution that has an ecosystem that is really engaging and is vibrant. So when JR said this, I went and joined Cumulus. I said, absolutely, we want to join. The first customer for Cumulus was AWS. They were completely redoing and reimagining networking because they were really forward-thinking. And they were forward-thinking because, again, they realized what not to play. They said, we are not going to play the game of L2. We are not going to play the game of QoS. I mean, how many of you remember how much we struggled with QoS in those days? They just said, we are going to increase the bandwidth. A rising bandwidth eliminates messy QoS. So that's what they did. So when I joined, and they were building their networks using 1RU switches, they were building it using unnumbered OSPF, and they were doing everything the standard way, except that they had decided that they were going to automate their network, and by giving them a Linux CLI, they could script their way out of every problem that they had, like Linux admins did. And so we thought, great, let's sell this to the masses. This is what you all want. Turns out that the mistake of OpenFlow was also a mistake we made because network engineers were trained not on Linux CLIs. They couldn't understand Linux CLI. They got in front of the machine, and they would hit tab, and they would get 1,106 completions. What do you want me to do? And they would be like, what? I got like set, open, show, just a few things, and now I get like 1,006. I don't know what to do with it. And I think the mistake from there is that you still have to remember that a solution that is going to succeed largely has to be something that involves the largest practitioners and allows them to start where they are. The clouds had greenfield networks. They had learned what not to play. They had scale, which meant, oh, I would love to do self-healing networks. You know how they solved a problem of a bad device? They just shot it in the head because they had so many boxes, and they rebooted the device. That's how they solve problems. But here we are thinking, like, I'm going to fire a script that does this, goes and changes the configuration there, and then no, they were not doing that. They were learning to walk before they could run. And I think a lot of us are very caught in by the magic that people put in front of us as network engineers, saying, your problem is going to be so simple because I can do this. And we go, wow. And then when we put them in our networks, turns out it's not a wow. It's a whoa. So they also built teams from the ground up because they were focused on automation. And like I said, because they used Linux CLIs, they changed the game. What do we have as the non-cloud operators? We have legacy or brownfield networks. We can't get rid of L2 just because someone said that's the way to do it. We have much smaller scale. We can't just shoot machines in the head because then we lose half our capacity sometimes, or half our servers go down. So we can't do that, and we completely lack the skills to pursue automation. We were like that lion, the leopard. We wanted to be able to go, but we were caged. And we wanted to be able to get rid of that cage. And I think this led to what I call the big bang of network engineers. A single primordial soup of network engineers split into two, the programmers and the non-programmers. And this split continued the problem that we had, which is it took a whole bunch of practitioners who were very skilled in the art and said, you cannot play this new game. You got to relearn the game. What was lost in this equation, however, was the fact that network automation, what AWS said was not, oh, network automation will just solve all your problems. No, you need good network design backed by network automation to create the robust networks which will save us time and effort. So for many of you who might say, like, hey, If I do network automation, will I lose my job? No, because your job is not hitting system reload now on 1,000 machines. It's something else altogether. I think one of the problems we have is the language we choose. And I was talking to somebody today, and they said, oh, finally, I have network automation completely in place. Great, what are you doing? Oh, I do config push and generate and push. Well, that's not network automation. I think when we say network automation, why haven't we seen full and adoption of network automation? I think because if you were 10 years ago looking at network automation, everybody thought config generation was network automation. Now it is all about validation. But there is more than that. We have planning, because this is the DevOps cycle which started the whole network automation thing. There is planning, there is building, there is testing, there is deploying, there is observing, there is feedback, and the cycle repeats. It's a cycle, it's circle, it's not one thing. And some of you might have seen this as a Mobius strip or an infinite loop. This is not my picture, but this is how you need to. So when you say full adoption of network automation, or I can do network automation, it's important to ask yourself, where are you in the stage and what have you automated? Because that is what is full adoption, and that is what is preventing us from doing full adoption, because we don't even sometimes define the terms. And if we don't define the terms, how are we going to set about understanding what problems need solving in each of these sections, and therefore what is really required? I make this really provocative statement that Python is the new OpenFlow. Why do I make that statement? I mean, it's obviously a bit of tongue-in-cheek. It's obviously meant to provoke a, really, dude? Seriously? Those of you who are falling asleep by my speech, thanks to jet lag, will hopefully wake up when they see the slide. But the bottom line is, the reason why I have this is because it's too low level an abstraction. I think by, again, asking people to spend more time than they have in order to realize the smallest of the benefits, you're preventing people. The one thing network teams don't have is time. That's the thing that I hear over and over again. Oh, we would love to deploy SUSE-Q in our network, but we don't have time. We got to go fight those fires. We would love to do this, but we don't have the time. Not having time is really critical. So anything that actually prevents us from being able to start here and now is going to prevent us from making that full adoption. But it's more than that. There is another reason why I think I call this the new OpenFlow. First of all, I don't think it's enough for people to say, learn Python and you're done. Because there are multiple design factors at each step in each of these cycles. You got to sit down and understand them. Understanding them and building them at scale. There was a LinkedIn article or a LinkedIn post by somebody who said, most teams that are trying to do their own thing struggle with scale and inefficiencies. If you got 1,000 devices, it's easy to automate something for a couple of devices in the lab. But when you got to do it for your 1,000-switch network, it's not the same. And then when there is a bug in your code, just imagine how long it takes to get there, fix it, come back. And this just basically said, you're like, dude, what did I just do? You remember the XKCD cartoon that says, do the job. Oh, I'm going to automate it. 6 months later, I'm still learning how to program because I'm not there yet, right? And so to me, there are multiple design factors. Some of the steps require actually fairly advanced programming skills. If you think about what is involved in observing, what's involved in feedback, what's involved in testing, it's a lot of complicated programming. It's not simple. And then there are, of course, the standard problem of shifting standards and technologies. So what are the shifting standards? First of all, I think we network operators are wedded to this belief of the myth of the uniform data model. How many times do you hear people say, if only the vendors could give me a standard API, then I would be all done. My whole automation would be so much easier. It's not going to happen, guys. The sooner we give up that belief in that, how shall I say, myth, then you're going to actually make progress. Why? Because we had SNMP, which was supposed to do this for monitoring, a much smaller subset of the tasks we have. That didn't succeed. Then we got netconf yang, which is SNMP with XML. And then we had openconfig, which was basically a bunch of big guys saying like, hey, I can't yet use 1RU switches. I want you guys to now give me, but I'm going to buy so many of them that if you don't do what I tell you, you're not going to be bought. So they did it because there was economic gravity. But the problems they solved were so small that now they can stand up and say, by the way, OpenConfig is the de facto way of configuring devices. And we have network automation forum Slack channel saying, did somebody listen to it? Is that what he really said? I don't know how is this working, because there is a lot of stuff going on that prevents us from doing this. And OpenConfig at the end of the day is just, my XML is better than yours. Oh, I have a problem. You use XML. Let me do GNMI. My encoding and RPC is better than yours. And then, of course, we have netconf push. You only push, I can shove. Why? Why do we keep on doing this? Is this the solution? So when people from the standards ask me, oh, what can the standards do? I say, get out of the way. We need zero standards. We actually need people to focus on the fact that a bunch of things don't change. And we also have the analysis paralysis. People say like, oh, I can get started on Ansible. I can do something simple. Terrible. Ansible can't do anything for you. You should get on Python. And now the guy goes like, oh, so I got to stop and I can't get on doing Ansible. Ansible is fine if you want to get started. I call Ansible the basic of programming. You don't have to do object-oriented programming to get started. It's fine to start with Ansible. Oh, and then, of course, we have the next group of people. Will Python constrict me? Should I go? No. Just start with Python. It's fine. For those of you who are advanced, maybe you want to get going with Go, but that's fine. You can go ahead, but don't mandate that. Don't push that on everybody else, because you're role models. When you say, I have automated, people look at you and say, oh, how did you do it? Can I copy it? And when you say, use Go, and they are like, should I use Ansible? You just have a complete disconnect that makes people actually stop. And this prevents us from full adoption again. So if you are really advanced and you're doing a lot of things, think about where you began rather than where you are. That makes a big difference. And then we also have these words like source of truth. And then we say, do I need a source of truth? And then you don't know what to do with it. And then people say, if you have a source of truth, you shall put it, because it has to be done logically, you shall populate it. But I have 1,000 devices. You want me to do a population of this source of truth of 1,000 devices by hand? I mean, I thought this was about network automation. But we have all of these debates that simply cause us to actually get paralyzed. And I think about the Peanuts comic. I remember this famous one where Lucy keeps telling Charlie Brown, hey, come on, kick the ball. This time you'll actually be able to kick it. And the poor guy always fails. And this is what we do with network operators. We change the standards, we change the languages, we change the ecosystem, we change, and we keep telling them, believe in the myth of the uniform data model, and they fall down every time. And then we say, why aren't we seeing network adoption happen? Because they are not seeing the benefits, because they have so many other things going on. Jeff Bezos said, I get asked this question, what's going to change in the next 10 years? But what's more important and more interesting is what's not going to change in the next 10 years, because out of that, I can build a stable business. And I think we can think about the same thing in terms of what can we do, what's not going to change for us to be able to do network automation. What's not going to change is vendors are going to continue to differentiate themselves. That's not going to change. So people who believe in the myth of the uniform data model, you can continue to believe in unicorns and fairies. It's not going to change anything. Developers will need to debug. And because the developers need to debug, you know what? The SSH and the shell command, the device CLI, will give you far more information than any uniform model will give you. When I was developing SuzyQ, I said like, hey, people would say, what are you using to pull the data? SSH. SSH? Why aren't you using OpenConfig? Why aren't you using Yang? Why aren't you using pick your favorite? I would be like, dude, I don't particularly care. When more of the devices actually have it, I'll add it. That's not a problem. They said, great. Next question. If you use OpenConfig or Yang, how will you get the vendor-specific data? So you put a problem on me and then you're asking me to solve it? Why? And devices have a long tail life. People who work with greenfield networks can say, I'm going to do everything with GNMI. But when I did SuzyQ and I just did JSON, one of the users said, Dinesh, if you use NXO as JSON output, I have 300 devices. If you do text FSM, I have 3,000 devices. And they're not going away anytime soon. So devices have a long tail life. So people who keep pushing new solutions doesn't work. That prevents us from making progress because we say, I have 300 devices I can automate, but I have 2,700 devices that I can't automate. What do I do with it? And these are problems that people don't always necessarily vocalize because they feel like they'll be laughed at maybe. But this is the real world that I talk to when I talk to network operators. I hear all the time. And another thing, oh, by the way, Dinesh, forget it. I just typed in my thing in ChatGPT and it just worked. It's magical. No. Testing and maintaining code will always take far more time than writing. And it's not sufficient as network operators trying to troubleshoot under stress or trying to get answers under stress to get an answer that's maybe right about 90–95% of the time. Because if I say that the problem is over there and the problem is really over there, I just messed up. And now you can no longer trust what it is that you're looking at. So it's important for us to not simply keep on waiting for the next thing that will be the panacea and solve problems for us. These are things that will not change. These are the things we can look at and say, I want to build something based on this. But I also think that we need to start looking at tools. In order for us to make real progress, we need to look at tools and what tools offer us, what are the right tools in order for us to make real progress. So we can stop the business of the mechanics of how do I pull data? How do I parse the data? Is it correct? Is it not correct? And every network is a snowflake. At the end of the day, it doesn't matter what people tell you, but every network is a snowflake. Microsoft doesn't build Azure the way Amazon builds it, does not build it the way Google builds it, Oracle does it differently. Everybody builds their network differently. Yes, overall they look like a class, but Amazon uses OSPF. Microsoft uses BGP. Google continues to use their SDN for a certain part of the fabric, and BGP for some others. So everybody's solution is different. So looking at and saying that I can somehow do everything from Python means as you move from organization to organization, your skills are all the time getting reset because of the way things work. And just having the basic tools doesn't help. Applications couldn't have made the progress they made if they said the answer is for everybody to learn assembly language. But that's what we are asking everyone to do. But as Andy Tenenbaum, in whose home country we stand, said, the good thing about tools like protocols is that there are so many of them. And you say, like, great, Dinesh, you said pick tools. But what tool? How do I even look at it? At least it was Ansible and Python. Now I have like 20 million tools. How do I even go about evaluating them? What do I do with them? How can I even think about them? I think it's important, again, back to those of you who don't know this movie, Arrival. It's based on the very old Sapir-Whorf hypothesis, which said language shapes thought. The way you describe the problem automatically lends itself to certain solutions. You say morning sickness, you get thalidomide. You think about asset management, you get an asset manager. You say source of truth, and everybody says, oh, this is the thing that's going to always have the source of truth. But what is the source of truth? There is not one source of truth. The real-time operational state is different from the policy state, is different from the configuration. So what is this thing solving? Is it an asset database? Is it an IPAM? Is it, without breaking down the problem and asking what a tool is solving and understanding, relying on a vendor or somebody else's, a gatekeeper and influencer's choice of words means we are falling into the trap that we are living by their words, not ours. Our problems are ours. We need to be able to describe our problems a little better. And then looking around, how do the compute people solve it? In Cumulus, where people were automating networks long before network automation was a thing, we didn't have NetBox. Even now, many people don't use NetBox. My take is don't use NetBox. No, it's not don't do this or do this. Ask yourself what it is that you want to do. What is the source of truth supposed to solve for you? So the words you use to describe the problem is important. The next question to ask is, which of these buckets does the tool fit in? If I'm going to do adding VLAN, that's planning. Does this tool help me solve adding VLAN? What is the tool doing? So without our ability to answer that question, we should not ask a vendor, oh, can I deploy it or whatever. The vendor should be able to tell you what bucket this tool fits in, or any tool that you pick, you need to see where it fits in. And the next thing for me is, how much time savings do I have? Maybe you have a very stable network, and all the automation courses are about Jinja templates and Nornir or whatever else. But you know what? You don't have that problem. If you start there, when your problem is that every day somebody asks you, where is this endpoint? Why can't I talk to B or something else? Automating config generation isn't really helping you. Asking yourself, what is the problem you have, and what is it that if automated will just give you back time is important. Also, how easy it is to get started. If the task to do is going to be a long time, then you're going to not get started on that, right? We always have difficulty starting when we are short of time, we are in stress, and now you tell me I got to learn something completely new. I don't know of network operators who have so much time on their hands that they can take all this time to learn. They always seem to be busy. Does anybody think otherwise? Do you think network operators have a lot of time? Do you have a lot of time?
I haven't seen my kid in years.
You know, you are at least aware that you have a kid. Maybe others are not even aware. So yeah, that's the point. But then we say, no, start completely from scratch. So I think knowing how easy it is to get started is important. And then the other question to ask is, some of the tools say like, no, you don't worry about VLANs, you don't worry about VRFs, we will deal with a high-level abstraction of something else. Great. When it doesn't work, how do I debug it? At that level? No. Then I have to log into the device and start looking at VLANs and vSANs and everything else. And then I'm like, so what did that solve me? Just config generation, nothing else. So now I might as well just learn the whole thing myself. So understanding what happens when it doesn't work is an important question to ask any vendor. And then there is, of course, the UX UI confusion. Different problems lend themselves to different mediums. I think today I see only two things. If it's a device CLI, it's fine. If it's not a device CLI, there's only one answer, the web GUI. Oh wait, I'm in network automation. It's the REST API, okay? But none of them address the problem that many times you've got interesting questions that you want your network to automate and answer for you that don't lend themselves well to a GUI. As someone said, you can't debug a dashboard, right? So if, for example, what's a question like that? Someone asked me the question the other day, one of these SUSE Q users asked me the question the other day, how many VLANs are there on this port which have more than 4 unique MAC addresses? Okay, it's a very specific question. I answered them with SUSE Q, but the question is, that's not an answer that lends itself to a GUI. So when you have a GUI and you're like, how do I ask this question because I have these dashboards and screens and there's really no way to query it, it doesn't work. So think about the medium. Don't tie yourself up to the medium that somebody offers. Think about the questions you have and whether a medium is better in how it addresses it. And some things, again, networks are not static. When people talk of source of truth, reject that statement. Say, I'm sorry, please redefine the model you're in because it is a source of truth, but it's a source of truth when? Because if it's a document, then is the documentation up to snuff with the code? Because the real world might have moved on and your documentation is out of date. You know, the source of truth, I think, came out of the word that people use spreadsheets to maintain things. And out of that, a better way to do it is something that is not a spreadsheet. But asking what a particular problem it is solving and understanding that networks are not static is important. And a bunch of people also don't understand that history matters more than you think and for longer than you think. Oh, if I just do this once, I think we are good. We don't have to do it again. We never have to look more than 4 days behind. A weekend is all the data I need. You know, I don't need more than a week's worth of data. No, I think you need it for longer than you think. In the past, And in the future, maybe if you start thinking about using forecast technologies for figuring out what might your network look like in the future. So I think history matters for more than you think and for longer than you think. And do think of multi-vendor tools. Remember, as a community, we have one thing going for us. We can enable a set of things, or we can unenable a bunch of things. The more we rely on vendors and their tools, the more we are wedded to the way they work, and they keep changing. How many times have you had a vendor change their favorite tool on you, right? And then when you move to a different organization and they use a different vendor, you're back to, I don't know what I just did. So thinking about the role of multi-vendor tools is really important. And here's a simple example of what I put together as some sample open source tools fitting in that bucket. In the planning bucket, you have a bunch of things. In the build, and this is not exactly, how shall I say, exhaustive. The packet pusher guys have put together a list. You can go look at it. Some others have put together other lists. You can go look at it. But the point is, look at these tools. Look at the ones that you have, and these are open source. There may be proprietary. There are proprietary ones that might fit in. But ask yourself, where do I bucket each of these tools that people are talking about? And how does it answer those questions that I've said earlier? So I would like to come to the summary of this talk, which is time is the most valuable resource a network team has. Anything that takes us away from time, that demands more time than we have, is a step in the wrong direction. Network automation is supposed to empower network teams, not replace them, which means you need good network design. Anybody who says, oh, I've got a crappy L2 network, if I automate my network, it's going to be great. No, it's not going to be great. You can't put lipstick on a pig and make it work. You got to ask yourself, what is the problem, whether the good network design, so your skills as a network engineer are not gone. And solutions and choices that rob us of time lower the chance of success. I think I already said that. And we need to automate the things that take up most of our time every day, not the thing that takes up our time once a year. And think about Tools 2.0. A new breed of tools are rising to address some of these challenges, and looking at them is useful. And I think tooling is going to be what's going to take us out of this area of where we are. And I think, ease of starting, start here. Pick up the parts of what is the easiest to get started on, what's the most mundane task that you automate, and start there. With that, I come to the end of my talk. You know how to reach me. I'll be in the hallway. If you want to come chat about anything, please do. I don't know if I have time for any questions.
Let me just give a couple instructions. So there should be a handheld mic at the intersection of the aisles and table. Did those get placed? Those two. Well, they're these two. Yeah. Okay, well, I'll pass these out. We've got at least 10 minutes for questions. So
I deliberately set up so that people would have questions. So please go ahead and ask me anything that you feel like. Tell me what you disagree with. Happy to have a discussion. This is meant to be provocative, meant to create a discussion.
And talk into the mic. Not just Stein, all of you.
Who's Mike? Who's Mike? Okay, so great. Just gonna hamper on one point with the network automation, like the NAT box as a source of truth, etc. Right? To me, in my camp of particular village people, it's not the NAT box, not about the SQL database, if you will, is the declaration of what should be, not what is. And when you say that the bookkeeping falls out of, as soon as you put something in by hand into the source of truth, it falls out of date immediately, right? But of course, you can't automatically just, oh, Johnny went and placed a couple of switches in the network. Well, we'll just add them to the source of truth. It's Tuesday. Fantastic, everyone. So what's your take on basically, like, do you view it just as a bookkeeping entry in your mind, or do you view it as something that, you should be able to spin out the entire source of your enterprise's network configuration out of this single, line-by-line tab, which some people get confused on and start trying to, I'm going to automate my entire network based on a device name and, the port configuration here, and good luck, everyone. So the real question is, like, do you view it as bookkeeping, or should we view it as something else, or a mix?
That's a great question, and that goes back to the specific point I was making earlier, which is, what is the problem it's supposed to solve? So one answer to that question is, if what you're using it for is holding data. Your templates are your code, the generation is your code, then that is data. So if it's holding data, then what do you need to hold the data? For example, let's assume for 1 second that I store the subnet from where I pull out the loopback IP addresses for my device, okay? That's stored in that thing, okay? Let's call it a thing because it's not a source of truth, so to speak. That doesn't change very often. So it's a great place to store it. And if you can also store what IP addresses have already been allocated, it's great for it to pull out the next IP address. But that's what an IPAM does. So should you be using an IPAM instead? Well, the answer depends on what resources you have, what budgets you have, and what you need. And more importantly, what's the simplest thing you need to do to get started? If all you're doing is writing a file, a YAML file, reading a YAML file, easy. Writing it into a database, fine. But the moment you write it into a database, the first question I ask is it version controlled? If it's not version controlled, trust me, again, what I said earlier, history matters for longer than you think. So it's important to be able to go back. You write it as a YAML file, maybe you use Git and check it in, and so now you have a way to go back. But whatever option you pick, there isn't one easy answer, but it is to your question, what is it? So for example, to your point, hey, I have a network, my source of truth is all populated, now I just threw in 2 new switches, what do I do? One answer could be, hey, add those 2 into your inventory of SUSE queue, have it take all the data, push it into Netbox, right? Now you have a simple way to automate that process, and then you can take care of a bunch of things. Now it didn't change your IP address subnet from which you allocated loopback IP, so that part can stay the same. A bunch of things like serial numbers which you had to enter, you didn't have to. So if you got an asset database, that's great. If it's not your asset database, then you don't need this sync. So again, asking that question is important. Does that answer your question? Perfect. Okay, cool. Thank you.
Hello, Dinesh.
Hey, Yanis.
Nice to meet you all here. I enjoyed your talk, obviously, and I want to address the point where you made about the data, where you mentioned the example with the MAC addresses. I think data is very important. And don't you think that most of the tools, and especially the vendor ones, imply a certain logic on the way that you need to access the data? They sort of tell you what you need to find out and what you need to do. And this is a big part of the problem. Yeah. I don't think even the custom tools and the tools that we're putting in place now actually solve that problem all the way. And I think this is the part where some of us go deeper and further down into programming for that part. And also, I want to say that it's a very important message what you said, that just start, and we'll figure it out along the way.
It's not just start. So thank you, Yanis. I completely agree with you that on 2 points. One is the questions you ask, the tools that you have need to be able to support you there. And that's why I have this particular slide, because if you have a GUI, you cannot typically ask that, right? And if it's not a GUI, maybe there's a hope of asking that. Otherwise, the next thing they'll ask you to do is learn some data science, SQL programming, etc., which is yet another hurdle for network engineers to cross. So I believe in those things are wrong. And so, one of the things when I did SUSE Q was to deliberately avoid that. So you're absolutely right. Asking those questions is important, and data is important. And more importantly, as they said, all models are wrong. Some are helpful. And so again, it's important from Yanis's point that the data you have is in a structure, a format that you can actually access. And again, here is an example. If you ask a vendor, a developer, how would I structure OSPF? They'll say, very simple. It's a structure, data structure. The top level is area. Underneath that are interfaces. Have you tried querying a complex structure like that versus a flat table where you can simply say everything with area 0? This is another example to my point of the data, the way you have, your ability to mash them together, mix them, do them is very important. And tools that don't allow you to do that are not helping you. That's a question you should ask. Completely agree with you, Yanis. Is that what you were saying? Exactly. Great. Any other questions?
One more, at least. You talked about how cloud had the benefit of starting from a greenfield environment and building new teams to support them. But you also mentioned the server, and you started out by saying, the server teams, how can the network teams get to the place where the server teams are? Setting cloud aside, what other characteristics did you see from the servers also started out in brownfield? Are there any characteristics, any features that we can take away as we start network automation from that whole thing to help us along the way? I'm hoping there's some patterns that maybe we could adopt.
Great question. So from the server people, I see two things. Sysadmins are really good at stitching together something that matches their business function, their whatever it is that they want done, with a set of tools that are already available. So they use tools, they write scripts to patch together a complex thing. If you think about Linux, there was the pipe operator, which basically took a bunch of functions and piped them together to create the end result that you were looking for. And different people strung together different pipe models to do what it is that they were interested in. And the little Lego blocks were good for a whole bunch of things. If you think about microservices, they are under some amount of attack because I think they went a little too micro, they maybe went nano. But the point is that they were also structured around the notion of composable pieces that you could then stitch together to decide how you wanted to do what you wanted. So I think from a network, from learning from the server admins, I think learning scripting is important, where it's not about you knowing all of Python and knowing how to write object-oriented programs, just basic, simple stuff. Learn the for loop, learn the if loop, learn how to stitch together simple stuff. That you can learn pretty quickly. Learning to write complex programs is going to take you much longer. Don't let somebody fool you to say, hey, I typed print hello world, it worked. I guess now I'm a network automation. No, it's not that simple like I already pointed out. So what the server admins do is they know how to stitch that together. So learning how to pick the tools, learning how to stitch together is something that they can do. The other is something that they have the benefit of, which we unfortunately don't, which is they have a shell which is programmable, which means they can do things that are not restricted to what the vendor decided. But it's 2024. Cumulus is in some ways a failed experiment because it's now a vendor operating system. But that's what we set out to do. We tried to make it so that you would get the ability to put whatever you wanted and be able to make it work. So lesson, yes, think about stitching together rather than doing everything from scratch would be what I would think about. What your skills are in learning Python, it's not don't learn Python. I think it's important. You don't have to learn Shell. Shell is terrible in comparison to Python. So learn Python, it's at least you can read it. As someone joked about Perl and Python, I can write the same thing in Perl or in Python. It's just that 3 months later, I'll actually know what the script is doing. Whereas with Perl, I have no clue what the heck it is doing. So it's similar in Shell. So with Python, you will actually know what's going on. So learn Python, but you don't have to get really complicated. Learn how to stitch that thing together. Yep.
Hello. I think you have very deep insight on how the network teams have experienced the adoption of network automation so far. And my question is similar to hers, but a bit more broad. How do you, what are your insights on the other teams that depend on the network, like the systems or applications or security team on this adoption? Because usually they are so dependent on the network that they might be a deterrent or a push for a specific solution.
Yep.
So what are your insights on the experience of these other teams with the adoption of the automation?
Okay. One thing I'll tell you up front, I'm not sure I have enough broad-based to be able to answer your question with some amount of, how shall I say, authority. And I say authority only to mean that, I have some experience in that area. I can take educated guesses, but I want to be always clear about what I'm making an educated guess on and what I really have enough experience with. So I don't have enough experience in that, but what I have noticed, however, is the following pattern. I've seen this over and over again. I gave a talk at LISA, which is Large Installation System Administration, many years ago. And what I heard from there was a whole bunch of people came to me and said, Dinesh, we know how BGP works. We know how OSPF works, but we can't touch the vendor CLI because I have no idea between Arista, Juniper, Cisco, how to configure OSPF, how to look at anything. Because show OSPF in one tells me one thing, in the other it tells me another thing, and they don't even use the same words. In one case it is metric, in the other case it's distance, in the other case it's something else. I don't even know what the words mean anymore. I think one thing that helps a lot for the other teams is the ability to have a normalized output. So what they have access to is data, not device. So when you have those, the first thing they'll do is they'll stop coming to you for those questions, which means now you have the time to say, get off my back, I've got other things to do, rather than answer your question of what BGP sessions are there, or is there a compromised thing or not. You can go type it in that particular thing and figure it out yourself. So I think tools or solutions, homegrown, not homegrown, whatever it is, to think about who are your consumers and thinking of them as consumers helps, and tools that help you from that perspective of providing access to data, regulated access. And I say regulated access as in having RBAC, things like that, so that people are not trying to muck around, is an important step in being able to address that specific problem. But beyond that, it's a little harder for me to answer something more concretely.
I think we're going to have to pause there just so we can keep the remainder of the track on track. But Dinesh, thank you so much. That was he'll be available for questions later too.
Yeah.